because so I'll take you through some stuff that you probably already know, but then it gets to some questions which I hope will make you think and encourage you to ask questions. I still introducing myself. I was on the CMEC, the Complementary Medicines Evaluation Committee. Don't sit too far away, please. For a while, which is how herbal medicines get regulated. It's a statutory body, was a statutory body at the time that made policy in the area of complementaries, and I was there as a medicine expert. And I did a master's at Sydney University in the pharmacy department, which was the conventional look at drugs and how these things are done, which was a bit of it sort of shattered a lot of illusions that I'd held for 20 years or more. And once your illusions have been smashed up, it's very hard to reconstruct them. So I'm still a bit like that. But I'm still I'm a believer in herbal medicines. Like, I love them and still do. But I'm not that big on the industry and all that sort of stuff. I like herb teas from a grower, or something like that. And I work for Floridas, but I'm not going to talk about Floridas all the time because I just want to, I just come to talk about what I like talking about, and that's how things are made. So that's it. I'll finish my introduction. Any take that?
Yeah.
So I've drawn this little diagram of a percolator, and we're just going to start looking at the basics of extraction and numbers. So don't glaze over for just a minute or two. It gets more interesting up to about an hour and a half. So let's think about how we make an extract out of the plant. We've got to grow it, harvest it, and if you're going to use a percolation, you have to dry it and powder it to a particle size that's appropriate to the stuff you're trying to extract. And then I won't go into the minutiae of how it's done, because there's a few little complexities to do with it, but basically you're packing the stuff evenly into a percolator. So in this case we're going to use a kilo of herb, and I'm going to choose hypericum perforatum, not because of any commercial interest, but because you can say extract equivalent to the dried flowering tops, and that's something I just like to say. So we've got a kilo of powdered hypericum perforatum in our percolator, and we pass a solvent that we decide what we're going to, what sort of solvent. And if we've done it properly, we're getting an even flow right through the edges. It's not that easy because it'll tend to attract itself down towards where the spout is. That's why you have a little layer, so that the gravity's even into like a t-shirt. But anyway, that is the point. So the powder's packed in the cylinder and the solvent passes through it and percolates through. You can do it with a vacuum on it, or under pressure, or you can have a heated sleeve around this so that it's done warm or hot. There's a lot of things you can muck around with. But fundamentally, you're trying to take all of the soluble materials out of this stuff and have it in a liquid. So let's pretend that we've got a kilo of herb packed in here, and we solvent coming through, then we've exhausted the mark, and now we've got this, just make it up, but now we've got 5 litres of liquid here, and that liquid is what we would call a 1 in 5 tincture, more or less. And it's not quite as simple as that, but for the maths, that's fine. Where and it's a weight to volume ratio, where 1 kilo is now in 5 litres by volume, and so 1 millilitre of the tincture is the equivalent of 200 milligrams, fifth of a gram of the dried liquid. But you can, is there anything left behind in this? Yes, there is. So it's not exactly the equivalent, even at this basic point. This stuff, if you dried it out, would probably weigh 4.8 kilograms. We've actually got rid of quite a lot of the dried flowering tops just to reach this extract. So your extract is the equivalent, and it's the extract you hope you've got the important bits in your extract. And there's a lot of assumptions about what you've left behind, but it's not useful. So that just to get you starting to think about it. Now if we evaporate all of the solvent of this, we'll probably end up with something like 200 grams. So I've taken this liquid, and whatever device we use to do it, we evaporate the stuff, and we'll end up with, the Hyperica might just know that you end up with somewhere around the 200 gram mark if you use, say, 50% ethanol, 45% ethanol. And so then that's an extract equivalent. So now this brown sludge, which we're going to call it powder, because it sounds nicer. This is the equivalent of 1 litre of the dried flowering tops. And now it's a 5-to-1 extract, and this is a weight to weight ratio where there are 5 parts by weight are now concentrated into 1 part by weight of the extract. So 1 gram of that is now the equivalent of 5 grams of the dried flowering tops. We still left all that behind. Now, yeah.
That 200 grams is it really sludge, or is it?
What happens is when you try to dry these things, they depending on the character of the herb that you're extracting, you get resins and components which don't really let go of the solvent very. They don't dry to being a powder. They dry to being hard, brittle materials, and they stick all over everything. And so what's done is you add a vehicle for the extract to attach itself to. It's not where I want it to go, but because when you buy these extracts, they often are a red powder or a brown powder, and they taste a bit sweet. That's because in the drying you add something like maltodextrin for it to adhere to form the powder. So you try and choose an inert substance for the extract to form powder.
So when these herbs are imported or exported or whatever, they're usually not
often, but there's no general. The generalisation is yes, but there's always exceptions to this because we're dealing with immense biological variation from roots, funguses, flowers, leaves, barks, what have you, with all kinds of different constituents. So here's something. Most plants, if you do this process, you will end up with, and you just make a simple extraction and you evaporate the solvent, you will end up with concentration ratios of between 4-to-1 and say 10-to-1. It varies a bit, but doesn't vary hugely because there's a certain amount of soluble material available to you, and it's usually in that kind of range. Okay. So here's your first challenging question. If the standard for importing a lot of these things is to buy a concentrated extract, and for example, if you buy a Cineris thistle extract, you would buy probably a 70-to-1 concentrate. So And if you did this with St Mary's thistle seeds and you powdered them and did it, you would end up with something like 200 grams of this stuff, and it'd be 5 to 1. So what is the 70 to 1 concentrate? How do we concentrate this to... I'm just going to go back to that call it hypericum just so that I'm not making it madly confusing. But if I want to concentrate that to make it into a 50 to 1 concentrate, how do I concentrate the extract that I've made when it's already a powder? How do I concentrate it? Yes. Can you take me through that? Like what? You're thinking along the right lines, but if I packed that in here and ran the same solvent through it again, all I'd do is redissolve that, and when I boiled it off, I'd add that again, with probably a bit of deterioration by whatever means I used to dry it. No, you're right. Something has to be done to it to reduce it. Anybody?
Take out.
You take out. You do.
Extract the parts that are in
Correct. Just as you have made an assumption with this that you don't want the fibrous material, which was quite a lot of it in the first place. Now you have to extract this again in another solvent or with another process to remove more of it. And in this case, to make the 50 to 1 concentrate, you would have to reduce this to 20 grams. Because then 1 gram would be the equivalent of 50 grams, and your 20 grams would be the equivalent of a kilogram. Don't get lost in the mathematics of it, but just understand that well, that's the problem with this, is the numbers make... You guys are into natural therapies because you love treating people and you're into health, not because you like to do complicated mathematics. It's good to have a bit of an understanding of this stuff, but it doesn't matter for the purposes of this lecture. As long as you can believe me, that to make a 50 to 1 concentrate, you have to reduce this to 20 grams, then you're okay. You don't have to understand how it works. But you've got to take a lot of it out. Then you've got this idea, okay, well if 20 grams is the equivalent of a kilo of the dried flowering tops, we're now talking about 4 teaspoonfuls being the equivalent of a great big bag full of dried herb. You've taken away a lot of it. And actually, if you do the sums on that, if you've got a 50 to 1 concentrate, you've actually got rid of, by making a kilo into 20 grams, you've got rid of 980 grams of the starting material. But you still call the extract equivalent to the dried flowering tops. Now that extract's got nothing to do with the dried flowering tops anymore. It's a few isolated components, chemical components of the dried flowering tops, but it's not the equivalent. So silymarin is universally used in the herbal medicine industry in Australia. There's different ways of it. But silymarin is just a group of flavonolignates, as I'm sure you've studied. And it's a very small part of the husk of the seed of St Mary's thistle. But on the labels of everything, the TGA require a statement based on the Act devised in 1989 and the regulations since, that A, calls it a herbal medicine when it's not, and B, requires the label to say it's an extract the equivalent of 14 grams of the dried fruits of St Mary's thistle when it's not. So the regulatory system forces a labelling mechanism which is just wrong. Now, that's interesting in the first place, but the other bit about this is what happens if I don't extract this efficiently. So let's say that I don't understand herbal medicine extraction very well, and I buy a big bag of hypericum that's just loosely chopped up, and I stuff it in the percolator, and I don't know why I roughed one out and then did the same thing again, but
Good answer.
that's it, yeah, thank you. Fine. And so say we had big lumps of stuff that we had in here, and the solvent would just flow in between them, and it wouldn't extract the stuff out of the tissues of the plant. But we could still percolate our solvent through and collect the liquid until it runs clear. It probably run clear quite quickly. And then we'd evaporate the solvent. What would, would there be more than 200 grams when we did that? No. Don't be frightened. If you haven't extracted it properly, if you've extracted it really badly, you're going to get less. When you evaporate the solvent, you might be lucky to get 50 grams. Because now 150 grams of, because you didn't extract it properly, there's 150 grams of stuff that was soluble, but you didn't dissolve it because you didn't do it properly. But if you don't know what you're doing, you take that 50 grams and you say, that's a 20-to-1 concentrate because it's an extract, the equivalent of a kilo, and it's just because you don't know what you're doing. It's a bit of a worry. Especially if you're dealing with hard, woody substances, which are made harder by ethanol. The ethanol is astringent and it hardens hard, woody tissues. So powdering gets much more important than the harder the stuff you're trying to extract is. So if you don't have a good machine for powdering things, and it's a coarse material that will pack in this problem it's very real, it happens. You buy things from some countries and they say this is a 20-to-1 extract, and you look at it and you know it's not a 20-to-1 extract. And it's just because they just didn't do it properly. And so you'll get, on the labels of products, you'll get some people who've got an amount of silymarin in a St Mary's thistle extract, and they say it's the equivalent of 20 grams of the dried fruits. And you'll get other people who say it's the equivalent of 10 grams. And it's who they bought it from and how they extracted it and how efficient their extraction was. In fact, the irony of it is that the most efficient extraction ends up with the lowest equivalence number because they did it well and they got all that was in that stuff. Isn't that strange? So all this war that goes on out there in the product land, we've got a bigger number in ours than you've got in yours, it often is completely irrelevant, because without you knowing how they did it and the efficiency of how they did it and what extract they used, you don't have enough information to say this is stronger